So far in all the Python code that we've written, we haven't anticipated any errors. When we write a function that adds two numbers, we always assume that the user will indeed pass in numbers. We don't imagine that the user will pass in strings or something else. But when you write code in the real world, you have to program defensively. You have to anticipate what errors will occur and take care to deal with them. We've seen errors in Python though, and we've also seen that we get an error message which will allow us to debug what exactly is going on. For example, the statement on screen is wrong in a subtle way. Can you guess what the error will be? What we have here is a syntax error, and that's what Python has told us. The syntax is invalid. After while true, it's expecting a colon, but we haven't specified the colon. This indicates that the Python interpreter does not understand the syntax. Let's see some other kinds of errors. What if we try to convert a string to an integer? We've seen that this is an error as well. This is a value error. The phrase used when we encounter an error in Python is that Python has thrown an error. A value error has been thrown. You can also say that Python has raised an error or an error has been raised. You'll notice that Python has specific errors for every weird situation that it encounters. If you try to perform a mathematical computation where you divide by zero, that is an error as well. Zero division error. If you try to use a variable before it has been assigned a value, that's an error as well. This is called name error. The name A is not defined. Or let's say that you're trying to add a string and an integer. This is clearly not allowed. This is a type error. You've tried to use the plus operand with types that are not compatible. You have a list with three elements and you try to access the fourth element in this list, the element at index 3. That's an error as well. Num list of 4 will give you an index error. The list index is out of range. And here's another one that we've seen before. If you try to open a file that does not exist, you'll get a file not found error. These errors have a specific name in programming technology. All of these errors are called exceptions. And it's pretty clear that Python uses exceptions in order to convey that something is wrong with the program, something is wrong with what you've done. Which means that if you have to write your code in a way that unforeseen things are handled, you need to be able to handle the exceptions in your code. You need to be able to handle the fact that the user might send in something that's not completely clean. Python gives you a special construct that you can use to handle exceptions, the try except block, and that's what we'll study next. Let's say that you are writing a program where you accept an input from the user. You expect that the user will always enter an integer and you want to do something with this integer. But anytime you accept input from the user, you have no control over what the user actually types in, which means you need to be able to handle exceptions. This bit of code accepts user input in an infinite loop. We'll break out of this loop when the user types in a special word exit. In all other cases, we expect that the user will input an integer, but we are accepting user input. It's possible that the user just types in a string which is not exit or something else which is not an integer. We have to account for that, and we do that using the try except block. Let's observe what's going on here. We have the usual code where we convert the user input to an integer using the int function and we assign it to the num variable. And after that, we want to print out yay, an integer. That's because we got an integer. These two lines of code are written entirely within a special block, the try except block. We have the try command followed by a colon, and then the next bit of code is indented in because it belongs to that block. And then we have the except keyword, and the except keyword is followed by value error. What this basically means is that when we try to execute the code that's within the try and the except commands, that code might throw a value error. And if it does, I don't want you to stop the execution of the program. Instead, you should move on to the statements that are in the except block. So if the user input an integer and everything is fine, there is no exception thrown, there is no error thrown, then we move on to the print statement which says, yay, an integer. However, if the conversion of the user input resulted in a value error, then instead of stopping execution right there, we'll move on to the code in the except block and print out, oops, not an integer, please try again. In summary, all the statements in the try block are the ones that will be executed so long as there is no value error. We won't even go into the except block in that case. On the other hand, the statements in the except block are the ones that will be executed if we encounter a value error anywhere in the try block. Hit Shift Enter in order to execute this cell. The first user input that we'll specify will be a string R. Now clearly this is not an integer, so we immediately go into the code that is in the except block which says, oops, not an integer, please try again. Now let's say our input was legitimately an integer, 5, then we'll simply print out yay an integer. We'll never go into the code that is in the except block. If the string input is u, then obviously that's not an integer, a value error is thrown, and we execute the code in the except block which says, please try again. If we type in exit, then the if condition which checks whether user input is equal to exit evaluates to true, and we break out of the while loop. We never get into the try except block. Let's take another example. I want to write a function which allows me to open a file. I specify the file name and the mode in which I want the file to be opened as input arguments to this function. I want to ensure that in case the file doesn't actually exist, the program doesn't stop execution. We don't throw an error and just throw up our hands and say we don't know what to do. I want to actually handle the case that the file does not exist and return none for the file handle. Now, you know from working with files that the statement which causes the error to be thrown is the open statement, the open built-in function. So you have to make sure that you invoke the open function within the try except block. The specific error that is thrown when a file is not found is the file not found error, which is why the except keyword is followed by the file not found error. That is the exception that we are going to catch here, and we'll return none for the file handle if that's the case. If there was no error, then we move on to the next statement where we return f, the actual file handle. Now let's use this function to read a file that we know exists. The students.txt file, we want to open it in the R mode, and we store the resulting file handle in the f variable. We can now call f.read to read this file, and we'll read all of its contents. This file existed, we never went into the exception situation. But let's say we open a file that does not exist. Here we call open file with the does not exist.txt file. The file handle will be none. So before you use the file handle, you have to do an if check. If f is equal to none, print out a message indicating that the file does not exist. Do not try to use f. Now let's change this open file function a little bit. It still takes in two input arguments, the file name and the number of bytes that we want read from this file. We do not take in the mode in which we want to open the file. We'll always open the file in the read mode. The first thing that we want to ensure within our function is that num bytes is indeed a number, an integer. So we try to convert num bytes to int using the int function. If by some chance the conversion does not work, num bytes cannot be converted to an integer, then this will be a value error. Once we've converted num bytes, we try to open the file in read mode. This can also throw an error, the file not found error, if the file name doesn't exist. We'll then print out all the bytes that we read from the file using the f.read operation. Now here, the except block has to account for two different errors. You can have the file not found error because of the open function, and you can have the value error when you try to convert num bytes to an integer. So the except block has to account for both of these. You can also save the error in a variable using the as keyword. So we are going to save whatever error occurred as the error variable. Within the except block, we'll print out the type of error that occurred and return none for the file handle. If we manage to open and read from the file successfully, we return the file handle f. Let's try to open a file that does not exist first. We want to read 2 bytes from this file. Here we get a file not found error. This is the type of the error that has been printed out to screen. We've moved into the except block and printed out the type of error. We'll try to open the file once again, but this time we pass in a string that cannot be converted to an integer, which means when we try to open this file, we'll get a value error. The error variable is of type value error because that's what was thrown. Let's consider the exact same function that we've seen so far. We want to open a file. This might raise a file not found error if the file doesn't exist. It might raise a value error if the num byte specified is not an integer. The one difference here is that we've initialized the file handle f to none before the try block. Now there is an implicit branching going on here that you're aware of. If there is no error, all the code in the try block will be executed. If there is an error, the code in the except block will be executed. Now, let's say there is some code you want to execute, whether or not an error occurs, whether the code in the try block is executed or the code in the except block is executed. You want some code to always be executed. If that's the case, you'll put it in the finally block. The finally block contains the keyword finally, the colon, and then the code you want executed. Here we are printing out in the finally clause. And if f is not none, that is, if the file handle is valid, we want to close the file. We first try opening a file that does not exist. This will throw a file not found error, but we still execute the code in the finally clause. We'll now open a file that does exist, but specify num bytes, which is a string and cannot be converted to an integer. This is a value error. The code in the except block is executed, as is the code in the finally block. Once again, let's try to open the file. This time the file exists and num bytes is also an integer. There is no error. The file should be opened successfully. We print out the first 7 bytes that we've read from the file, which is the name Kishore. The code in the try block was executed, as was the code in the finally clause. So far, we saw how we handle exceptions that is raised in Python code, Python built-in functions, and so on. However, it's also possible for you to raise your own errors when you encounter some kind of bug in what the user has input or something which doesn't sit right. This is a way for you to signal from your code that an error has occurred, something has to be looked at, something has to be handled by the calling code. Here is a function that does something very specific. It adds two numbers, a and b, passed as input arguments only if the numbers are under 100. Only adds numbers up to 100. This code requires some error checking. If we find that the value of a that the user has passed in is over 100, we want to raise an exception, and we do this using the raise exception command. Exception is a built-in class that is available in Python, and it is used to signal an error. In fact, all the errors that we've seen so far derive from this exception base class. The way to throw an exception from your code is to call the raise keyword and then instantiate an exception object. You can pass in a message for the exception when you instantiate this exception object. The message is used to indicate to the user what the error was so that he or she can debug. Here we say the value a was greater than 100. It was actually %s, and we specify what a was. If you find that the value b is greater than 100, you'll raise an exception as well. You'll say the value b was greater than 100. It was actually, and specify what the value was so that the user can debug. In all other cases, we can add a plus b and return that to the user. Adding two numbers here, 2 plus 55, this should work just fine. 2 and 55 are both under 100. We get the result 57. But what if we want to add 101 and 23? This will be an error. Our exception has been thrown. Notice that the error type says exception because we instantiated an object of type exception. And the message is the value a was greater than 100. It was 101. Or let's try passing in a value of b that is over 100. We pass in 230. This is an exception as well. The value b was over 100. It was 230. Specify a nice, friendly, and helpful error message to help the user debug. Let's say both of these numbers are over 100. A is 101, B is 230. Then notice that the exception which is encountered first stops the execution of the program. We first check for the value of A and raise an exception because it's over 100. The execution of the program has stopped. We never check the value of B. Let's say that your code can throw any number and any type of exception, and we only handle a few of them. Here we have a class called raise exception, and here are the list of exceptions that it can throw: keyboard interrupt, value error, index error, file not found error, and type error. All of these exceptions are built-in exceptions in Python, and we've stored them in the exception list. Now, based on the value of the input argument num that has been passed into the raise exceptions class, we raise that exception from the exception list. If num is equal to 0, we'll raise a keyboard interrupt. If num is equal to 1, we'll raise a value error. Num is equal to 2 will be an index error, and so on. We raise this exception within a try except block. But in this try except block, we only handle the keyboard interrupt. We do not handle the other exceptions. This means that if we raise any of the other exceptions other than keyboard interrupt, the exception will not be caught. The program execution will stall. Let's try this. Raise exception and passing in a num value of 0 will raise a keyboard interrupt, which is handled. And you'll find that this works just fine. We go into the except block and print out handled only keyboard interrupt. Let's say we invoke the raise exceptions function. We pass in a num value of 3, which means this will raise the file not found error. The file not found error is not handled by our except block, which means the program execution will stall. Our Python program raises this exception and just stops. Notice that our file not found error does not have a corresponding message. This is because when we instantiated the file not found error object, we did not pass in an error message. The error message is empty. We are going to define the same function once again, the raise exceptions, and we have the list of exceptions, but we want to write code such that all of the exceptions that have been raised or can be raised will be handled with one except block. In order to handle any and all exceptions that might occur within the try block, you will have the except block, but you will not specify a specific error or an exception after the except keyword. You'll simply have the colon. This means handle all exceptions. When you omit a specific exception after the except keyword, all errors are handled by that except block. We'll call raise exceptions and pass in a value of 0 for the num variable. This means that keyboard interrupt will be raised. That has been handled. As an exercise, you can call raise exceptions with other values for num, and you'll find that all of the exceptions are handled. Our code goes into the else block and we print out the statement. We'll go through the same demo once again, but this time you want to handle exceptions, but you want to customize the handling for some of the exceptions. Let's say you want to treat value error a little differently and the rest of the exceptions in a certain way. You can do this as well by specifying multiple except blocks. We have the same list of exceptions as before, and we want to raise a specific exception as specified by the value of num that is passed in. But this time, when we encounter a value error, we want to print out handled value error. So we have a specific way to handle the value error. If the exception that was raised was a type error, we want to handle that a little differently. We want to print out handled type error. In all other cases, though, we want to handle it in a general or a generic way. In all other cases, such as keyboard interrupt, index error, file not found error, we want it handled by this last exception block, which doesn't have a specific exception type associated with it. The most important thing to note here is that the general purpose except block, which doesn't handle a specific exception such as a value error or a type error, should be specified at the very end after all the specific exception blocks. Think of it as the fall through. Let's invoke the raise exceptions function. We pass in a value 1. This will cause a value error, which is explicitly handled. We pass in a value 4 for the num variable. This will cause a type error, once again explicitly handled. Let's try raising exceptions with the value 2. This will go into the general purpose block, which handles all kinds of errors.